Hello, this is Mrs. Taylor, and I just wanted to go over the process of using your graphing calculator to graph a linear equation. So the big thing here is that TI-84 graphing calculator, y has to be by itself. So you always make sure y is isolated first before you even begin this process. And I would like to go over number 2 here because y is not isolated, and so I want to review that process. So in order to isolate y, this 3x needs to move to the other side of the equal sign, and so does the 4. And remember, when we're trying to isolate a variable, we undo the operations that are happening to that variable. So to start with, we have 4y plus 3x, and I can undo that addition by subtraction. So if I have 3x plus 4y equals 0, then I can subtract the 3x from both sides. 0 minus 3x, well, that I can either write out just as 0 minus 3x, or I know that the 0 would basically disappear because 0 minus 3x is just negative 3x. So either way you can write it would be correct. The last thing to isolate the y is it's 4 times y, so the opposite of multiplying would be division, and so I divide everything by 4. Now 4 divided by 4 is 1, and 1 times y is y, so those 4's would what we call cancel out. And then when I divide an expression that has multiple terms, so I have a 0, and then I also have a minus 3x. I have to divide each term individually by that number. So 0 divided by 4 would be 0, and negative 3x divided by 4, well, it doesn't divide out to a whole number. It would still be a decimal. And so the easiest thing, especially since I'm using a calculator, would be to leave it as a fraction of just 3 divided by 4. Don't forget your x. So now I have my y isolated, and now I can use my calculator to graph this. And again, I don't have to put the 0, but I'm just putting it here as a placeholder for this example. So this would be y equals 0 minus 3/4 x. Now I'm going to type that into my calculator. So what I would do is I would press my y equals, which is up here, and I would type y equals is already there, 0 minus, and then 3/4 is just division. And remember, when we do fractions in the calculator, we have to use parentheses. So I would press parentheses 3 divided by 4, and that gives me that fraction of 3/4. And then I need my variable x, which is this button here. That's the shortcut to a variable. And then I could just press enter, and now I have stored my equation into y equals. Now if I just want to see what the graph looks like, I can press graph and get an idea of what that would look like. Now I need to graph this by hand. And so one way that I can do that is I can use a table, because if I can get a table of values, I can plot those values on my graph and make a more accurate graph than just kind of sketching this line. So if I go to second and then graph, that is also a table. The word table is in blue above the graph button, and anything that's in blue I can get to by pressing second. And if I look at the graph, or excuse me, the table on my paper, it starts at -2, and this one starts at 0. But that's okay, because I can just press the up arrow to get to the values that I need. So -2, the y would be 1.5, -1 would be 0.75, and then I get 0, and -0.75, and then -1.5. So now I can plot each of these pairs. at first you may be a little intimidated because it's decimals, but remember a graph is just an estimate. So we're just going to estimate where those decimals are. Now I know where -2 is, the x value, it's here. And then 1.5 would be about 1.5, so up 1 and then about halfway there. And then -1.75, or -1 and then 0.75, somewhere in between 0 and 1. And I know I'm going to make a straight line because when I looked at my graph, that's what I had. So I know it has to be kind of in a line. So my next point is 0, 0. So that would be here. And then I have 1, -0.75, so down here. And remember, it kind of has to be in line. So I'm estimating, but I'm also trying to get it to line up. And then 2, -1.5 would be about here. And so now I have some specific points on my graph so that when I connect them, I have a much more accurate graph than if I had just sketched from looking at the graph on the calculator. So that's our goal with this, is to create more accurate graphs and have a little easier time of it. The other side wanted you to use the intercepts, and so just really quickly, I'll do number 3 since it's already solved for, or y is already solved for. So we have -1/3, so again a fraction is in parentheses, and then x -2, and if I graph that it looks like this. But for number 3 and 4, it asked you to use the intercepts to graph, and so I need to know where it crosses the x-axis and the y-axis. Now, we did an activity that showed you that the calculator will calculate the 0, which is the x-intercept, but you could also use the table, so I'm going to show you how to do that. If you go to second table, remember that the x-intercept is where y is 0. So I am looking for the point where y is 0. And so if I look at my table, I can see that the values are getting smaller, bigger and bigger towards 0. And so if I go up a few more places, I will see where x is 0. X is 0 when, I misspoke. I will see where y is 0. Y is 0 where x is -6. So the coordinate for the x-intercept would be -6, 0. And I could plot that point on my graph. Now the y-intercept is where x is 0. So I am looking for the coordinate that has 0 for x, and if I scroll down, I can find that coordinate here, 0, -2. So that would be my y-intercept. And then once I get those two intercepts plotted, all I have to do is connect them. So the intercepts are an even quicker way to use your calculator to graph a pretty accurate line when you're given an equation. So that's how your calculator can help you graph linear equations.